Hello, guys. I wish to go over these two questions. And the first question, of course, is pretty straightforward, but I still have some, there's some points I'd like to explain to you. And number two, and I will show you a couple of different ways of doing it. We did it one way in the class, and I would like to show you some other ways to do it. All right, so this one, the first one, to find critical numbers, the function is defined and continuous on the entire number line, okay? And its derivative is going to be a polynomial. And polynomial is also defined and continuous on the entire number line and differentiable. Okay, so the function is differentiable, this derivative is differentiable. So we're not going to have the kind of critical numbers that are, that will cause the denominator. No, sorry, that's going to cause the derivative undefined. Okay, so this should be the most straightforward. Everybody should know how to do this. Okay. All right, so we have 12x raised to the power 3 plus 24x squared minus 96x. Okay, so looking ahead, we're going to find critical numbers by setting the first order derivative equals 0. So we're going to factor. It looks like 12x will be the common factor. We will end up with x squared inside the parentheses plus 2x minus 8. Then we're going to factor more if you like. Some people stop factoring here and handle the parentheses by a quadratic formula. That is totally okay. Okay, so we got 12x. And however you factor this is going to be x plus 4 times x minus 2. So then we're going to set the first order derivative equals to 0. So when we set it equals to 0, what we get is that we have the entire thing equals to 0. Obviously, 12 is not going to be 0. So if we divide both sides by 12, then we will divide both sides by 12, we will get the next equation equals to 0. Okay, I wish to point out some people note, some people divide both sides by 12x. Okay, some people divide both sides by 12x. Can we do that? Can we do that? The answer is no, unless you specifically say x cannot be 0. Because x is the domain of x is the entire number line. Therefore, you cannot divide by 12x without saying that x cannot be 0. X cannot be 0. Okay? So if you do not specify this, that will be a mistake. That will be a mistake because x is equal to 0 or not is not certain in your division. Okay? So please don't do divide by 12x. And also, if you divide by 12x, you're going to be, at the end of, finding your critical numbers, you're actually missing a number. Okay? So we get to this point, and by mathematical principle number 5, that will be either x equals 0. So there are 3 cases that we could leave this to 0. So x plus 4 equals 0, or x minus 2 equals to 0. Okay. And so then we will get 3 numbers. We'll get 3 numbers as solution. X equals 0 is the solution. X equals to -4 as a solution. X equals to +2 as a solution. So our critical numbers Our critical numbers are -4, 0, 2. Okay, so this should be most straightforward. The algebraic knowledge you needed was very basic algebra. Okay, very basic algebra. If you have issues with that, please review algebra. Okay, especially mathematical principle number 5. Mathematical principle number 5 says, okay, if A times B equals to 0, then A equals to 0 or B equals to 0. And then you may say, oh, we have 3 factors. Yes, we do. We have 3 factors. This property can also be extended to 3 factors. Okay, so any one of the factors equals to 0 will ensure the product equals to 0. So this is the mathematical principle number 5. Okay, but it also called zero product property. Okay, zero product. Sorry, I need to make some changes to the fonts. Zero product property. Okay, zero product property can be extended if you have 4 factors, A, B, C, D in products. Okay, 5, 6, 7. Okay, for the same reason, So this property can be extended to more factors. Okay. The second one, we did one kind of methods. Okay, which is we're going to take a derivative. Okay, I'm glad that I see some of you got it. And I even come up with other ways to do it, right? The way to handle algebra questions has never been unique. There always more than one way to do it. Okay, and so we're going to take a derivative. So this is going to be product rule. If you want to show this step, be sure you put the part you want to differentiate in the parentheses or a bracket. Okay, but you can totally skip this step. You can then you go to 1/3. Okay, and x raised to the power of 1/3 subtracting 1. So that will give us negative 2/3. Okay, most of you got this part, so I'm not going to spend more time here. You easily did 1/3 minus 1 equals to 2/3. So the second factor stay unchanged, and the second part of the product rule is that we have x raised to the power 1/3 unchanged. We're going to differentiate the part in the brackets. So we got 2/3, and then 4 raised to the power of 4 minus x. I'm sorry, 4 minus x. This is going to be using change. So this is -1. So 2/3 minus 1 is going to be negative 1/3. Negative 1/3. And then we have to differentiate the part in the parentheses, which is going to give us -1. Okay. And if you like to reorganize your terms, you can do the next step, which bring the -1 to 2 with 2/3, and that's going to give us negative 2/3, and removing this -1 here. So you can put the 2/3 in the front. So this will be more a conventional way to write it. Okay, and then the common rule of thumb. The common rule of thumb, okay, as we understand it, is that we're going to factor. The way I taught in class was to factor. And some of you really got it, but some others may not have got it, where you find it a little difficult. You need more practice, but at the same time, I wish to show you, okay, so after I show you the way we did it in class, I will show you some other ways to do it, okay? So the rule of thumb is to factor it out with each base, okay? So we have two bases here. We have two bases here. One base is x, the other base is 4 minus x with the lowest exponent. Okay, we're going to factor out so we're going to factor out this piece and we're going to factor out this piece. But this part doesn't have that. But this factor does not have 4 minus x to the power negative 1/3. So there are a couple of ways to do it. Okay, there are a couple of ways to do it. So you want to create something like that, right? Excuse me. You can write 2/3 as 1 minus 1/3, isn't it? 1 minus 1/3 is 2/3, right? So this way, nothing else is changed. So this 1 minus 1/3 equals to 2/3. So x raised to the power 1/3 is equals to, okay, equals to 1 minus 2/3. Okay, you can do it this way. Okay, you don't have to do that. And my way was creating 0, but creating 1, right? Multiply by 1. You can do it this way. Well, if you do it this way, then what's next, right? You're gonna split this base to 1 power 1, and you're gonna split this to the power 1, and you're gonna split it another time, right? Bring this negative 1/3 to this piece. So this piece is from here, okay? This piece is from here, okay? Same base. And for x to the power 1 minus 2/3, you can do the same thing. So you can just write x raised to the power of negative 2/3. Same thing. Right, so you can totally do it this way. Power 1, we can omit it, right? Product, and power 1, we can omit it. All right, and then you're going to factor out the part you want. Okay, next we're going to factor out the part we want, and we also have a 1/3. We're going to factor. Okay, so we put everything in the bracket if you want. So what's going to be factored out? 1/3. 1/3 out of here, 1/3 out of here. That's going to have a 2 left, right? X to the power 2/3, x to the power 2/3 out. So it goes here. X power negative 2/3. And the other base, 4 to the power of negative 1/3. And bring it here. There you go. So inside the bracket, you're left with 4 minus 3x. Okay, so this is slightly different way to do it from what I did in class. Same thing, really. You can do it these ways. Okay, so we get to this place. We get to this place, and then what? And then what? Then we can set, because we have the factor form, right? We have the factor form. And knowing that these terms with negative exponents is going to be in the denominator, so we need to guarantee the denominator is not 0. So you don't have to do this, but you can. If you want to see better for yourself. And the other one is 4 minus x raised to the power of 1/3. So we convert all the negative exponents to positive exponents, which they're gonna be in the denominator. So the top would just be 4 minus 3x. Okay? Now is the moment we're gonna determine the domain, the critical numbers, okay? So knowing the domain of the original function, which is all real numbers, negative infinity to positive infinity, right? So every real number is defined for this function, but not for derivative. The derivative has a different domain. Okay, so what's the domain for derivative? Well, we must guarantee the denominator cannot be 0, right? So x cannot be 0. And x cannot be 4. X cannot be 4. Okay? So now we see two numbers. These two numbers are in the domain of the function, but not in the domain of the derivative. So these two numbers are critical numbers by definition of critical numbers, right? Because the derivative is not defined as 0, and the derivative is not defined as 4. So we got two critical numbers in this case, okay? Once again, x cannot be 0, x cannot be 4. That's the domain for the derivative. The function itself has, all real numbers as a derivative. So let's review the critical number again. A critical number C. What kind of critical numbers? What kind of condition critical number C must satisfy, right? Critical number C, for, of course, for f of x. For f of x, right? There are two conditions. There are two conditions. Number one, C is in the domain of f. So C is in the domain of f. Domain of f. Okay. Secondly, right? There are two cases. There are two cases. Okay. One case is that the first order derivative of the function as C is 0, or f f of C does not exist. Does not exist. So there's a category, one category. There's one category here, sorry. One category here. And the second category would be B, which, derivative is not defined there. Okay, so 0 is such a number, right? It's in the domain of the function, but it's not, it's a point where the derivative is not defined there. 4 is the same thing. So these are the two critical numbers we already found. But we have another critical number, which is we're going to set the derivative equals 0. We're going to set derivative equals 0, okay? So we're going to set the derivative equal to 0. When the derivative is set equals to 0, numerator must be 0 because denominator cannot be 0. So 4 minus 3x would be 0. Okay, this will lead to another critical number, which is going to be x equals to 4 over 3. Okay, so in the end, we got three critical numbers. Okay, we got three critical numbers, which are 0, okay, 4/3, 4 over 3, and the last one, number 4. So I have three critical numbers, okay? So as I promised, I'm going to show you another way to do this. Okay, I'm going to show you another way to do this, is that we simplify that, right? So we got this piece, all right? And so I'm basically gonna use this form. I'm gonna use this form, all right? So that's our derivative, all right? Because this is where we can take a different approach, okay? So another way to simplify to find critical numbers. This way, okay, so we got it here, so we basically just finish up the derivative. We have not a factor. And then we're gonna set it equals to 0. We're gonna set it equals to 0, right? So we're gonna set this whole thing equals to 0. Okay, if we set it equal to 0, we basically have, you know, one term subtracting another term equals 0, right? And if we move the subtraction part to the other side, we will get this piece equals to the other piece, right? We're just adding the second part, 2/3 x raised to the power 1/3 times 4 minus x negative 1/3 to the other side. So the question becomes solving this equation, okay? So we can multiply 3 on both sides, right? We can drop the 3, 1/3, multiply 3 on both sides. So this side will be left with 2. And then what do we do? Okay, we need to make some assumptions because for the operations we are going to do, we have to assume that those quantities cannot be 0, right? All right. So now, first of all, we actually can determine domain. From here, we can determine domain here. Why is that? We can actually determine domain here. Why? Because first we have x raised to the power negative 2/3. So in this case, x is going to be in the denominator. So x cannot be 0. Second, 4 minus x to the power negative 1/3. 4 minus x cannot be 0 because it's a negative 1/3 power is going to be, 1 over 4 minus x. Okay, so I'm going to rewrite this so you know exactly what I'm talking about. Okay, so why we can determine domain here. So this is going to be 1 over x raised to the power of 2/3. Okay, this piece stay there. Okay, so you can see x raised to the power 2/3 is in the denominator. X cannot be 0. So that's why we determine the domain for the derivative that x cannot be 0. Minus 2/3 times 1/3, that part doesn't have any 0, anything in the denominator. However, 4 minus x to the power negative 1/3, if we change it to a positive power, that's going to be 4 minus x to raise to the power negative 1/3. We put it in the denominator, becomes positive exponent. So we got another term in the denominator, and this term cannot be 0. And so that's another point that x cannot be 4. So at this point, we already found the 2 critical numbers. Okay, at this point, we already found 2 critical numbers. So we got 2 critical numbers already. Okay, but we may find, but we also have to set the derivative equals 0. Okay, we also have to set the derivative equals 0. So we got 2 critical numbers already, which are 0, 4. But the question may not be complete because we have to set the derivative equal to 0. So when we set the derivative equal to 0, all these operations all of these operations is done in the domain of the derivative. Okay? The following operation on f prime are done in the domain of the derivative, which means that x cannot be 0, x cannot be 4, so we will not have zero denominator issue. So now we can do our operations, right? What do we do? Well, how about we multiply this piece, right? We multiply this piece on both sides with, okay, I'm going to show you. I'm going to multiply two things. I'm going to multiply 1 with 4 minus x times the positive 1/3. So I'm going to multiply this piece on both sides. On both sides. Can I do that? Yes, if this piece is not 0, and we have guaranteed this is not going to be 0, because 4 cannot be x. All right, so we need to be constantly thinking, what is the implication of it? So we multiply these two, and what do we get? Sorry, this piece equals to 4 minus x raised to the power of a negative 1/3 plus 1/3. Okay, so I'm just going to show you very briefly. And this two piece is going to be negative 1/3 plus positive 1/3 because they have the same base, right? If they have the same base, and that's going to be their opposite, so this is 0. 4 minus x is not 0 because we have the guarantee it's in the domain. So anything to the power 0 is 1, provided the base is not 0. Okay? So what do we get on the left-hand side when we do these two? Well, this is 2/3, and this is going to be plus 1/3. Okay, still the same base. And 2/3 plus 1/3, that's the power 1. Power 1, we can omit it. Do you see what I'm doing here? And we can do the same thing for x raised to the power of negative 2/3, which is we're going to multiply on the next. I'm doing this as a to show you. Okay, you can do it much shorter. Okay, so you multiply x raised to the power of positive 2/3. I'm going to multiply these positive x raised to the power positive 1/3, 2/3 on both sides. This one can be omitted. Now what do we get now? This piece is going to make 1, right? Times 1 stay, and this piece is going to be what? X. So what do we end up with? We have 4 minus x equals to 2x, right? Solving for x, we get 3x, we get 4 equals to 3x. And in the end, x equals to 4/3. So this is the other way to do it. But in this part, you have to understand these operations. It could be a little bit longer. It could be a little longer, but you need to understand the conditions when you proceed with that. You proceed with the operations. Okay, so let's look at another way. Okay, I call it the third way to do it. The third way to do it. Okay. So the third way to do it, maybe this is the third way to simplify the derivative. okay, is to use the radical form, okay, the root form, all right? So you're gonna write it as 1/3. And over here, you have this x raised to the, oops, sorry, x raised to the power of 2/3, right? And this is the numerator. This is your numerator. Subtracting 2/3, right? Subtracting 2/3, and you have a denominator, right? So you're going to turn this into a positive exponent. So that's going to be 4 minus x raised to the power of 1/3. 1/3. So you can bring this guy, just bring this guy over to the top. It's just some simple algebraic operation. So bring the 3 here, put the 2 there, there. So put your 3 here. There you go. So you have a fraction form. You have a fraction form. Okay. How do we deal with these fractions? Common denominator. Common denominator. So what will be the least common denominator? 3 times x raised to the power 2/3 times 4 minus x to the power 1/3. So that's our common denominator. So this piece, okay, we got that. We just didn't have this piece, right? So I'm going to multiply that, top and bottom, top and bottom, there, right? Subtracting on this piece, what do we don't have? We don't have x raised to the power 2/3, right? So we're going to multiply x raised to the power 2/3 over x raised to the power 2/3. So this is 1, this is another 1, so anything times 1 stay the same. And then what? Well, now we got the same denominator. We got the same denominator already. Look at that. We got the same denominator, right? So we just have to, simplify the numerator. When we simplify the numerator, look what we got. 4 minus x to the power 2/3, 4 minus x to the power 1/3. So the top is going to be 4 minus x raised to the power of 2/3 plus 1/3. And that's going to be 1. Okay, that's going to be power 1. Oh, sorry, power 1. Power 1 can be omitted, right? So we have the same denominator. We just bring them together, and there. And the same thing for these two, right? X to the power 1/3, x to the power 2/3. So this is going to give us what? Never mind, I'm sorry. So this is going to make 2 times x. Same denominator goes there, right? So we now got the same denominator. It's just a matter of keep the same denominator and combine the numerator. I'm almost done. Almost done. Okay. So this will give us the 4 minus 3x. The good thing about this operation is that some of you may like it, so I present it here. And then there's some miscellaneous ways, and you can try your different ways. And I certainly saw other ways of doing this. It's all good. It's all good. Forgive me, I don't want to make this too long. And please practice with that if you have issues. But you definitely need to know how to do the first one. The first one is considered the simplest case. Everybody should know how to do it. Everybody should know how to do it. And if you need help, please let me know. Thank you for watching.